a problem that we saw when we were maintaining some infrastructure, and we were regularly having to shell into servers. So just a little bit of really critical backstory on each of us. And the three of us are all on a team where we're working on things like enabling all of the development teams at our company to create code and behavior and ship it to production as quickly as possible, and then get feedback on how it's behaving in the environments that it's deployed to as easily as possible. We're also working on things like, provisioning infrastructure with tools like Terraform, securing our passwords and secrets with tools like Vault, and just generally, anytime a development team comes to us and says, could you stay up all night and press this button to restart a server, we're trying to provide things like self-service tools so that teams can do that themselves. And by the way, we are hiring if anyone is interested in talking to us. I actually have a stack of business cards I almost never use. So if you have to run out the door right after the presentation is over, just grab one and reach out to us.
So are you running Bitcoin on your...
If John is, he hasn't mentioned it to us.
That's right. Yeah, they don't know, so we don't talk about it too much. Yeah, like that comment there. I just got out of Bitcoin because I don't know if you know, but it's like half the value that it was last month. So. Yeah, no, I got out before the fall. So. I know you've been having a good time. You have to, right.
So the challenge that we were seeing and that we want to talk about today is all three of us were regularly shelling into servers and finding out we didn't have access to those servers and having to go ask somebody for an account or a password or to provision an account or a password. And then we would do things like copy our pub keys up and set our passwords, and different servers would have different rules about the characters that had to be in your passwords and frequencies, and we'd have to go update our passwords in all these places, and a big hassle thing that we could find a better way to do. Have to look for something. Also, we wanted to get a handle on, like, when somebody switches teams within the company, making sure that their accounts got removed off of boxes that they previously had access to. So we looked at some different options. Having local accounts with passwords or pub keys and using Unix level permissions to control what people have access to on the file system. Sudoers and sudoers can control what commands they can run. We had tried that manually in a lot of places, and that was where we were seeing this challenge. And we had also tried starting to experiment with scripting the provisioning of accounts with Ansible and things like that. But inevitably, we were seeing things like if we would try to roll accounts across several boxes, there would be different rules in place about what the passwords had to be. It would be difficult when some things were inaccessible and other things were, to remember to go update the things that failed the time you tried to provision things across lots of boxes. So we thought, well, let's go grab this AD LDAP integration, which is through a Linux level authentication plugin called PAM SSSD. And we connected that up to our LDAP, and we would shell into boxes, and everything was great for a little while. And then we started seeing some really weird behavior where we'd shell in and something would just hang for 30, 45 seconds. Even though the AD server was by all other observation up and running and responding to requests. So this sort of rubbed us the wrong way and led us to the point where we had experienced enough pain that we started thinking there's got to be a better way to do this. So we looked around out there, and there are some companies that make solutions you can buy off the shelf that do things like act as a proxy server and control authentication and sync accounts across boxes or provision them on demand. We weren't ready to spend money yet, and we're looking for something that was very straightforward to manage and understand, and to be able to control our access to machines and give other people limited forms of access to machines and have all that managed in one central place. So we found a, I think we've already talked about this actually. So we found an article that Facebook had written about using some built-in capabilities of OpenSSH, where you basically, you can set up a certificate authority and then put that certificate that you generate from that certificate authority on servers, and then have a way to sign your personal pub key to allow you access to a role and a user within a given box in a way that when you shell into the Unix box, it doesn't depend on anything else to be up and running. It just decrypts your authentication that you are you and your permission to assume a given role and user and lets you in. So that's what we're going to talk about today, is using built-in capabilities of OpenSSH and key signing your public keys to allow you to assume user accounts on different boxes, to let you kind of partition access of who can assume what accounts, who can show into what things, in a very manageable way that doesn't have any external dependencies once you have a signed key that gives you access to a thing. So AD can go down. We're not dependent on any sort of vendor up and running agents anywhere. This is all just straight OpenSSH. So with that, I'm going to hand it over to John to do a demo, which is basically going to take you through most of this flow.
Sure, yeah, thanks. All right, so I just want to talk about the diagram for a moment, but right before I do that, how many of you are already doing passwordless login to Linux hosts? All right, so a good fair number of hands went up. And the way that you do it currently, do you take an RSA keys public key and you put it into the authorized key file on the server? Is that the workflow that you currently use? The command copy ID, and it shows up over there, and then all of a sudden you can log in everywhere. Yeah. You upload a PIM key to AWS, and then you can log in, kind of thing. So the pain you might not experience it if you're in AWS, but if you're not in AWS, the pain that you feel is that you have to run that SSH copy ID command for every single box and without a password. Okay, and so the beauty of what we're going to be presenting tonight is that you won't have to do that anymore if you implement this solution. And so we'll show you kind of how that works from a proof of concept level. We'll also get into an implementation that, but really there's a lot of different ways that you could implement this, and there's a lot of different tooling that you could also use to implement this. So we're not necessarily going to tell you this is the way to implement it. We're just going to show you our ways, and maybe you can be inspired, so that way you don't have to run SSH copy ID everywhere anymore. All right, so here's an overview of, or here's a sequence diagram of how this works. As a user, you have to generate a private key, so that's still the same, and a lot of you probably already have a private key. But then over here, we're going to generate a certificate authority. And so really, this is just another private key that also comes with a public key that does decryption and encryption for other keys. And so we'll kind of see how that works. So you have a cert authority server that generates that key pair. And then what you do is you take the public key of the key pair and you install it on any SSH boxes. So instead of you running SSH copy ID, you would just deploy this one public key to all your servers. So any number of users, they don't have to push their specific pub keys up to servers. You just do it once for the certificate authority. And so then from there, what happens is that you as a user sign your public key, and then you can log in to the box by giving it your public key that's signed, and it compares it with what it knows from the certificate authority. So that sounds like a lot, but as we do this demo, I think you're going to see that, hey, that wasn't so hard, and hey, this is pretty cool. So,
one question.
Yes.
Go back to the chart.
Yes.
I guess I'm lost as to you're making that certificate authority, that pub key for each role you want to.
Mm-hmm. No, you're doing it once for the certificate.
How does a user sign in as different roles?
Right. So we're gonna show that as part of the demo.
That's the key.
Right. Yes. Yes.
I'm sorry. The CA means a certification of.
Right.
Yeah, just kind of to elaborate on that answer a little bit, the magic is where SSHD decrypts the authority that you've handed it, and it looks inside that thing and says, is this person allowed to assume this user? If so, I will let them into it. So it's kind of encrypted in the thing that you hand the remote server.
Right.
Cool. Let's see how this stuff works. And so what we actually have is a GitHub repository as well. And we just made it public today. So you should be able to access this. And then we've got a pretty big README. So hopefully it should be able to help you out as well. But we'll be going through some of this. And so, yeah, you should be able to follow along, hopefully. So, well, we've actually got two implementations referenced here in this repository, and what I'm going to demo first is this first implementation. And so this is the implementation where we're actually creating our cert authority. And the second implementation will be replacing that with Vault, and Ryan will be showing that off. But let's do this, and as part of our implementation, just make sure that everyone has the same starting point. We're using Vagrant to spin up boxes that are clean. So that way you don't have to worry about environmental details or issues as you try to follow some of this stuff. So I'm going to assume there's a terminal somewhere. Here we go. And check my path. All right. So I'm in here. Yeah. I'm going to run Vagrant up because that's what we had over here. So, so what gets spun up when you run this Vagrant up command are two VMs. It's going to use VirtualBox in this particular example. The first VM is our CA server, and so that's where the signing action actually happens. The server that spins up acts as an SSH host or a remote server, one you would go and log into. So we'll see how that's going. Okay, so that's still spinning up. Let's see what's inside of that Vagrant file. So can everyone see that? Is that big enough? Yeah. All right. So so up there at the top, this here represents the CA server, and so all it's really doing, it's spinning up a CentOS 7.4 box, and once it spins up, then it's going to run these commands here, which basically just creates a directory called /vagrant/myca, and then it's going to run this SSH keygen with these arguments, and it's going to say yes to any prompts. So it's just whatever prompt, it's going to just say yes. To create the public key, and then over here for the SSH host, this is the other box that's also going to be a CentOS box. And then basically, it's creating some variables here that are local variables. It's got a little function that helps me modify the SSHD config, here's where it's actually doing stuff. It's going to copy the pub key that we spun up on the other server into this path right here. And then it's going to update the SSHD config where the key is trusted user CA keys, and it's going to put in that path. And it's going to restart SSHD. And then finally, it's going to create a new Linux user that where password login is disabled. That's what the -D is there. And so the user is just called ops. So in practice, what this means is that if I have a signed pub key, I'll be able to log into this box as the ops user. Let's see how it's coming. All right. So that part is done where the two VMs have been spun up. So let's go down here. So in order for this stuff to work, I need a private key. So this is the part where you're probably already familiar with that. So let's run this command here. I'm going to skip a passphrase for now. And then if I see what happened, there's now a myops key and a myops pub key that is inside of this directory. I mean, if I inspect the stuff, it's going to be what you expect. You know, private key is there, and now it's not private. So I guess you guys see it now, but it's fine because I just generated it. I'm going to throw it away. So just for you. Okay, so next we're going to log in to the CA server. I'm going to take that command there. Okay, so now I'm in the CA server where I can sign my pub key. I'm going to paste in this command here. So it signed the pub key and then exited me out of the server. Now you can think, like, if you were managing this process within your organization, every time someone wanted a pub key signed, they would have to come and bother you. So if someone needed to log in somewhere where they required a signed pub key to log in, and let's say you were sleeping, well, then you would get the call to go and sign their pub key. So that can be a bit cumbersome, and so that's why we have the other implementation that we'll talk about in a little bit. But I do want to mention some details about this command that was run on the signing server. So it runs the SSH Key-Gen command, and it passes in some params here. The first one represents identity. So servers that do the signed pub key method, they actually do some auditing as part of that. And so this -I, this represents your identity. So we can know who was it that logged in here as a user. And so we get some of that metadata. This -N represents the user that you actually want to log in with. And so in our case, since we created that passwordless ops user, we're going to pass in ops here. And cool thing, now we're not necessarily going to go too far into demoing it, but you can replace this ops with a group. And it's not a Linux group, but it's called a security zone. And so it represents a collection of users that can do something interesting. So like, let's say you have a collection of people that should be able to sudo into the box. Find this for that security zone, and then anyone who has a signed pub key that was signed with that parameter, they'll all be able to log in instead of it just being to a specific user. The -V specifies the duration. So this will last for 1 week's time, basically. So it'll expire at 1 week, in which case you would then need to get your pub key signed again. All right. And we can also inspect this signed pub key that was just created. So do that there, and we'll take a look at what this says. So you can see that the key ID is the container store, so that represents our identity. It's valid from today to next week. You can see that there, the week timeline. And then principals is ops in our case. And then over here represents permissions for things that I can execute in my SSH session. I can do X11 forwarding, I can do agent forwarding, and other cool stuff like that. Does that all make sense? Next, I want to try the process of logging into a box. So I'm going to get the port of the SSH host. And in this case, it's going, 22 is port forwarding to 2200 on my host. So that's what I'll log in with. And then here's the command that I'll put in here. And yes, and I'm in. So I didn't have to provide the password. And I was able to get in here. And so what I'm doing is I'm passing in my opt private key. I'm passing in the signed public key from the CA, and then the server that I'm logging into and the port that it's serving on. So so basically, I can now distribute well, not this one, but the CA's pub key to any server. My signed pub key, I can now get into all of them. And so any of the people that I work with, their pub keys could also be signed, and then they can also get into it for the duration as long as it's valid. So so it gives you better control and better access to more stuff, and you don't have to remember to SSH copy ID all of your individual public keys. Make sense? Yeah?
So the public key is signed. Typically, you sign that. That's a one-time thing. You don't change it. So basically, when you get the host, it should verify and get signed as a certificate.
Yes. Yeah. So so what we've been doing is taking our CA's public key and distributing it to all the servers in our farm. So that way, any new person that comes on, if they sign their personal pub key, then they can get into any of the boxes that they should have access to. So they didn't have to do the dance of SSH copy ID. We already did it once with the CA pub key.
What are you doing on the servers that you're logging into? What are you doing on their end to let them know to check that CA? Or
right. So when we were looking at the Vagrant file, this is the part that does all that magic. So update SSH config is just this little function here that is just doing a key value replace inside of the file. And it's saying this key, we're going to map it to this path. And that path represents the CA's public key.
That's an option in the SSH.
Exactly.
File.
Yeah. And so this is the part that like kind of blew my mind. Like this existed all this time? And yeah, I had no idea. Right.
That's the man page.
Is that in the man page? I don't know.
And of course, in our example with using the ops user, you'd have to have that user on the box already too. Like
right.
Account for that user.
Right. And so that's also what's being provisioned there. So it's creating the ops user and disabling the password so nobody can log in with the password. Seriously. Yeah. Cool. All right.
So basically, proxying your SSH.
Well, so here's
getting it over to the CA server.
Yeah. So it's not quite a proxy though. One of the really interesting parts about this is that it doesn't have to talk to the CA server. It doesn't do any of that stuff. What it has is the CA's pub key. So that's a file. You can distribute that. It's not going to make any network connection back to it. So unlike our original solution with Active Directory and centralizing it, and every time you log in, you have to do your 80 password, and it would do that check. Well, there's latency involved in that, and it was causing additional pain for us. This, because it's just a file, is going to do the decryption right there and analysis right there, and then you'll get in, and the box could even be offline that whole time. So if it has the signed, or not the signed, but the CA's pub key installed there, and then you have the box off your network, but isolated in its own network, and you had another box that was on that network, but you also had your signed pub key, then you could get into it still. So totally offline, it would still work.
You don't have to have a copy of that pub key or anything on the server?
No, so the CA's pub key you do, but yours.
SSH trusted.
Right. Right, and so that's when it's being generated there. Yeah, at the provision time, when your VM is spinning up, that's when it's adding it. Cool. Make sense? Cool. All right. Let's see if I have anything else on this part.
A nice caveat.
Yeah, yeah. Well, I mean, so the caveat here is that that you, as the manager of the CA server, because like one thing you don't want to do is take like your root CA and distribute it to everyone. That would be really, really bad. That would be a security vulnerability. And so, yeah.
You want to control access to the CA.
That's right.
Normally you put that all on. I'm going to ask, what's your MSSP say about all this?
Yeah.
Well, to be clear, like we've simplified some things for the example.
Yeah.
Like you could generate an intermediate and base everything off of that. So that's kind of the way to go when you're scaling this stuff.
Well, I can see my security guys already resisting me on the fact that you have an offline access to the box. So if I fired somebody tomorrow, they could conceivably have access.
So this is where that TTL that John was pointing out comes in. Remember the flag that said it's like 1 week? You could tune that down to like an hour or 3 hours or whatever makes sense for that job role. And after that time expires, they can't show into the box.
Yeah.
But you also just have to delete their account. The other side of it.
I still got to compliance policy.
Yeah. So yeah, and so the caveat though is because you're the only one who has access to signing people's keys, then everyone has to funnel through you to get signed keys. And so that means that you are the bottleneck, and that can be really painful. And so,
It's a one-time thing, right? Not every time you do that.
well, yeah. I mean, if your signed pub key only is valid for 1 week, then they're going to come see you again next week.
Right.
Every time.
And yeah, every time it expires, they got to come see it.
If only there was a way to solve
If only there was a way to solve it, and we do have a way to solve it. And so that's what we'll be demoing next in the next implementation, where we use Vault. So, Ryan, take it away with what is Vault.
Okay, what is Vault? Someone mentioned Vault in here earlier. Yes. So is anybody in here using Vault for anything?
Oracle.
Huh?
Oracle got a Vault.
Okay, using Oracle Vault. Okay, so the Vault we're going to be talking about is a tool from HashiCorp. For those who aren't familiar with HashiCorp, they make a lot of tools in the DevOps space. I see a HashiCorp sticker right there on my laptop. So they make Packer and Vagrant, Console, Vault, Terraform. So before we dig into the details of how we're using Vault, I just want to touch on a couple of Vault concepts. And like John alluded to earlier, or Matt alluded to earlier, Vault's basically used to help you protect and manage secrets. So passwords or certificates or tokens or things like that that you don't want to have, that you want to have access to. So Vault has a notion of authentication to verify that you are who you say you are. You can do a very limited sort of username and password in Vault without any sort of external integration, but it also integrates with GitHub. It authenticates with LDAP, so Active Directory. Integrates with, I can't remember one of the other big like identity providers. AWS, yes. So we're using, in our particular case, we're using its LDAP integration. The primary means of authenticating with Vault is a token. So the typical workflow is you authenticate with Vault and prove that you are who you say you are, and Vault will give you back a token. And a token is what you will use to perform all the other activities, either writing secrets, reading secrets, creating policies. All of that is dictated by what authorities are granted to you via your token. Vault controls authorization through policies. So policies, when you obtain a token from Vault, a certain number of policies are applied to your token. And those policies are what dictate what you're able to do. So what secrets you're able to read, what subset of secrets you're able to read, what sort of administrative tasks you're able to do in Vault, whether you can edit policies, create policies, delete policies. All of this is driven by what policies are applied to your token. And then Vault has a notion of backends. We can kind of think of it as sort of pluggable modules into Vault's encryption kernel. So it has a notion of what we talked about before, authentication. These are all authentication backends. It also has some pretty interesting secret backends. One of the other, just kind of a side note, one of the interesting functionalities of Vault we've been talking about experimenting with is it can dynamically generate credentials on other systems for you. For example, it has a database backend. So the solution would be, hey, I've got this production issue, and I need to go actually connect to our production database, maybe fix some data, maybe look at some data, but you don't want to just start granting, read-write privileges to all your users. What you can do is someone can authenticate with Vault and obtain a one-time use username and password that is good for, say, like an hour to do whatever production support needs they do, and within an hour, Vault will be responsible for making sure that username is expired from the database. But it has some really cool capabilities for use cases that I've got as well. So in the scenario that John talked about, how we are using it with Vault is Vault acts as our certificate authority. And there's two ways you can do this with Vault. The way we chose to do it is you can say, hey, Vault, create a new pub private key pair and give me the public key. And in that case, you will never see it. Remains encrypted inside, and you will never see that. Another way you can do it is if you already have a private key that you use or a root CA, you can create an intermediate certificate and you can load that in the Vault. It just kind of depends what kind of risks, what kind of like how you want to implement it.
You want the continuity to go.
Right. So in this case, it was super straightforward to do it, and the risk of the private key being exposed was 0. The only risk you really run in this case is if something happens to Vault and the whole system, for whatever reason, is cratered and vaporizes, you lose that private key, and therefore your public key is null and void. Therefore, getting to so we've kind of mitigated that in a certain way as well.
I assume you do a DR for your CA.
Yes. Yeah, we have our Vault running in high availability mode backed by console, and we're looking at ways to actually have another replicated offsite. Huh?
Tested.
Yes.
And one of the nice things too about this is like if you lose your Vault, but you base all this access control of all these servers on this standard OpenSSH stuff, as long as you kept some redundant copy in a safe place of your CA key or your intermediate, you can still go to those low-level commands to do stuff if an emergency happens.
Yeah, so we've tested this doing rolling updates and taking servers down. We've also had some involuntary testing of some recovery of this as well. And then the next step is Vault provides a HTTP endpoint for doing the public signing. And you basically, once you have authenticated with Vault, you will pass in your public key to Vault and say, I would like you to sign my public key user and give me back a signed public key. And we'll see how that workflow works in a second. So before I mentioned Vault governs, the authorization is governed through Vault policies. So obviously anybody can say, hey, Vault, here's my public key. I would like you to sign it and authorize me to log in as, say, an ops user that has elevated privileges. Well, Vault has policies that will only allow certain users to hit that endpoint, and all other users will get a 403. For us, that is driven, is that next? Yeah, so policies that are applied to your token are driven by what authentication backend you're using. In our case, is LDAP. So the end-to-end workflow works something like this. So I will authenticate myself to Vault using my Active Directory credentials. Vault will turn around and ask AD, are these credentials good? And they will get back the list of my security groups I belong with in Active Directory. Vault will then map those security groups to Vault policies. And then when I go to sign my public key and I hit the endpoint I hit is basically determines which user or role I will be authorized to when I sign my key. The authorization to be able to do that is driven by what policies were applied to my token. Does that make sense? Okay. So let's see that in action from the command line. So what do I need to do here? I lost my terminal. Okay. Oh, am I still in the bigger box? Yeah.
Oh, yeah, yeah. Destroy it first. Yeah.
I see that.
Oh, hey, it'll still.
It escaped the wide to the wide.
All right.
Winner, chicken dinner.
Why?
Yeah. Okay. So I'm going to spin up. In this scenario, we're going to have one VM running. And should we go in and take a look at that one? So this one has some kind of important stuff to this vagrant file. So is this actually connecting to? Yes. So what this vagrant file is doing, the really important stuff is right in here. So once this box is spun up, this is actually going to our Vault server at the container store and downloading the public key and adding it to the box that we're spinning up. So that sequence diagram, the part where we go and grab the public key out of our CA and go put it on all the servers, that is replicating what that step is. So instead of an admin doing it, that's what we're doing. So at this point, when the box comes up, it's going to have RCA's public key on it. And it should be just about done. Okay, cool. Let's see what our next step is. Okay, is this for generating a public key? So I'm going to use my, like if I look, and probably everybody's directories look like this. So I have my private key and public key already. I'm going to actually, yeah. So I'm going to use my already existing private key and public key for this example. So the first part I mentioned was I authenticate with Vault. So here I'm going to authorize with Vault, and here I'm using Vault's command line. Under the covers, this is just hitting Vault's HTTP API. I'm using the Vault command line. So I'm going to authenticate with Vault using the LDAP. It's going to prompt me for my password. And here is my token. So now I've authenticated with Vault, and I can actually go in and look. So this lets you inspect any token. If you don't pass any arguments, and inspect your own token. So this is the thing that I want to point out where we have policies. Notice I have this is the critical one, the admin policy. This is going to let me do the things that I need to do in Vault. So what happened was I authenticated. Vault, the AD passed back the groups I'm in. Vault said, what Vault policy should be applied to this union of all the groups that I got back from Active Directory. So that's how I got these policies.
Don't forget we're being streamed.
Yeah, we'll revoke the token when we're done. Go, go, go.
There are so many other barriers that would have to be jumped through in order to.
Right. Yes.
Okay. But yes, we're going to revoke the token after this stream.
Don't worry, it expires
Excellent
in 20
points.
minutes anyway.
Okay. So then I'm going to copy this. I'm going to make a couple of edits. Actually, I should have this in my history. Okay. So at this point, this is the part where I'm asking Vault to sign my public key. So what I'm doing, I'm hitting the SSH client signer sign ops endpoint. That is an endpoint that we created. That's basically effectively saying sign my public key and sign it as, so I can log in as the ops user. Get the response back, and then I'm going to redirect that output into my home directory into a file called idrsa-cert.pub. And one of the reasons I do this, you will see in a second. So now I have a signed certificate in my SSH directory. And now I want to go inspect it.
But change the name.
Yep. RSA, is that right? Nope.
Oh, because it's in your SSH.
Yep. Good grief. Oh, that. Okay. Now we're inspecting the signed certificates. There are a couple things to note that are a little different than the last time we looked at it. The ID now, as you can see, what was generated by Vault. So it is a unique ID, but one of the interesting things you can see is how I acquired this signed public key. And you can see that it has my username. So this key can be identified as where it came from. And this is who I can log in. I can log in as an ops user. And this has a relatively short TTL on it. I believe this is, where does it expire?
12 hours.
12 hours. So it's good for 12 hours. So it's pretty much good for a longish working day. So, and I think someone asked a question earlier about what do you do if somebody leaves and they still hold on to something that gives them authority to log into servers. That was part of the decision, at least that we made, is by the time the day rolls around tomorrow, everybody's going to have to re-authenticate to prove that they can have the access that they say they should have. This is going to expire in about 20 minutes. Okay, so now I should be able to. Well, that's not what I wanted.
SSH host, yeah. It's just vacant port because there's only one box this time.
Should be 2222, right? Mm-hmm. All right, so now I'm going to SSH into our command.
That was the host, P2222.
All right, so I logged in. So, so one of the reason I specifically named the signed public key ID RSA-cert is by convention that's where SSH will look for that key. So you don't have to pass in any extra argument. So in this case, that SSH, I'm logging in almost exactly how I log into any other box. Probably the biggest difference is I'm logging in as that role of implicitly what my. So that's really the only difference of how you will start SSHing into other servers.
Is your user on that box, or is it just the
It is not on that box. Okay. So how, at least how we have set it up, is we're provisioning these servers with more as roles. So in this case, we have an ops user that has elevated sudo privileges. We've also created a group for a DBA group that allows them to do some elevated commands. They can assume the Oracle role or the Oracle user that exists on that box. They can assume the Postgres user that box. They can do certain privilege commands like starting and stopping the databases. We've talked about having this even for like a subset of other teams at our company, particularly like a development group, to be able to log in and do authorized commands, allowing groups of people access to this box, particularly those that have people that are, like if you're hiring a bunch of new people, it's kind of painful to keep provisioning new accounts and who's going to what box. This kind of alleviates all of that pain.
Yeah, even though there's no RS Breidenbach user on that host, there is traceability back to you just shelled in.
Yes.
Through the identity that we were just looking at in the
track.
Yes. So you have an audit trail when you sign that certificate. When you signed your public key, there's an audit trail in Vault, and there's an audit trail in the audit log on whatever host you signed into. You can see, even though I'm assuming the ops user, you can see what the actual identity of that user is. Can we see that? We can't see that here.
So you'll have to go in as the Vagrant user, which that's fine. You can just do, exit out of that and just do Vagrant SSH. And then it's in var log secure. Yeah.
Oh,
yeah. Sudo cat or sudo more, whatever. See how his identity is in there, LDAP. Yeah. Yeah, and each identity actually gets assigned a TTY as well. So over here, so if you have multiple users that are logged into the box, the same ops user, we can map this. So it'd be like PTS/0, PTS/1. We can map that to the specific identity of who's on that box, even though they're using the shared ops user.
And one of the other things to mention is when we talked about having a relatively short TTL and having people re-authenticate. So every time you have to re-authenticate, you're going to need to authenticate with Vault, which then authenticates your credentials with Active Directory. Active Directory is the first touch point whenever somebody leaves our company. That's the first place that account is disabled. So that kind of turns everything off from that centralized point of authentication, at least from our workflow.
That's really the only point at which something else needs to be done. Like I'm now re-signing my key to start my workday. LDAP
Yes.
has to be available.
Yes.
But once I sign that key, LDAP can go down and I can for 12 more hours.
And it's fair to say that Active Directory is pretty critical to.
And your CA is always up.
Yes.
Well, in this case, the CA is Vault.
Right.
Yes.
My company's sensitive about having CAs up.
It's like not having them, like.
No, just, they want them offline most of the time.
In this case, we never know what the private key is.
Right.
In this, yeah, so because Vault generated it and immediately
You're
encrypted
leveraging it critically, which is a different, implementation. And I get it. I like it. I just don't know if I can sell it.
Sure.
I think that's the end of this demo. And I think.
So on your journey through all your challenging solutions, were you using Access at all?
What's that?
Remember to repeat the question.
Oh, sorry. So so you asked, are we using Adaxis, right? Is that the name?
Yeah.
And what is Adaxis?
It's another LDAP.
Okay.
So.
Yeah, so if it's an LDAP authentication, then it could be a drop-in replacement for AD for the Vault integration.
I don't think it has the same features. Could be wrong.
Yeah.
I like this. I just don't.
But that's okay, because that's why we showed the other implementation,
Right.
because that's actually more approachable to people that don't know Vault. Like if we say, oh, in order to do this, you have to do Vault. Well, okay, great. Now I've got to learn how to spin up a Vault cluster. Oh, great. Now I have to learn how to do a highly available backend with console. Oh, great. Do I do multi-data center with me on-prem and then some nodes in AWS? Like it could go on and on and on.
Yeah.
So we took this as a win because we already had some of that infrastructure in place. The easiest thing to gravitate to for our use case. But yeah, we demoed the regular CA route because that's more approachable for people that don't already have some of that infrastructure.
I like that route for a lot of stuff that don't have on
And man, if you want to get to the database, you will use a database backend within the box to get another token. There's no it's so passing through. You have to get a token for each role you want to impersonate from that box. That token is just logging to that box. And is that right or not?
When you say token, you mean like Vault's token?
Yeah, well,
Well, the token you get is basically your personal identifier,
yeah.
and then all other activities with Vault, you use that token. Necessarily used by people. Lots of, this is kind of getting off the SSH topic. We have lots of processes in our company that use Vault for obtaining secrets. We have some database migration processes that use that our database passwords to perform automated database migrations. Vault is a tool for us, I would say probably in the last year that we've gone through kind of the experimentation to adoption to this is a core part of our infrastructure in a lot of ways. And we're just kind of learning how it's solved more and more problems for us from a secret management perspective. And the one I mentioned before, that's kind of another one that's kind of in the, we want to experiment with this, because that's another problem that's very much like, how do you manage access for all of the people that need to access things for all of your servers? You can ask the same question about all the databases you have. How do you make sure that all of the people have all the database access they need at the right privileges? This is a possible answer for that without having to have a local user for every single person in your company, every single database they might access. Another use case.
And it scales to RDS as well.
Mm-hmm.
Yeah, so because you can have a Postgres or an Oracle or MySQL RDS instance, and it all will manage the user accounts and privileges the same out there as it would on-prem. Other questions? Cool.
All right.
All right. So that's it for today. So thanks a lot for coming. I do want to do a quick announcement that we are looking for additional organizers as well for DevOps Live for 2018. So if you have some bandwidth, you want to help schedule some speakers for us, then get in contact. Or if you're interested in helping us organize the conference, DevOps Days, keep in touch as well. And so yeah, that's it. Come talk to me in a couple minutes if that's in your realm of interest. Cool. So otherwise, we'll see you next month.
thank you.
Thanks.